This is a great problem we've been doing nearly since the beginning of the year. It says find the equation of this line of it should be the line of the line through the points negative 3, 2, and 3, 6. There's a couple different strategies we have, and we've been looking at one most recently that kind of involves systems of equations. I'm not going to use that technique here. Instead, what I'm going to do is do what we did earlier on. I'm going to identify the slope and then figure out what the y-intercept based on the slope in one of these 2 points. So remember, our definition of slope is it's the change in the y values divided by the change in the x values, and whenever we're showing change, that's a difference in 2 numbers. So I could, for example, write the change in my y as 6 minus 2, and if you look at here's a y value and here's another y value. So I'm just taking the second y value and I'm subtracting the first y value. And then I'm going to divide that by my change in x. My first x value, the second x value, I'm going to use this one, is 3, and I'm going to subtract negative 3. So I write 3 and then subtract negative 3. Notice that I'm moving from this second point to the first point each time. So I've got 6 minus 2 and then 3 minus 3. So it's important to keep that order correct, or else you'll end up with the wrong sign of the slope. Right now for my slope, you can see my numerator is just the number 4 and my denominator is 3 minus 3 is 6, and that slope reduces to 2/3. So the slope, alright, this is m, the slope of my line is 2/3. That's one of the 2 parameters we need to define the line. The other parameter is the y-intercept, and the technique that we've most often used now is considered just an equation, a generic equation in slope-intercept form, y equals mx plus b, and we use the slope that we found, right? We found that the slope was 2/3, so that's going to go in for the slope, along with one of our 2 points. And I like the look of, let me erase this. I like the look of this point. That looks cleaner. So we're going to use the y value and the x value from this point, and we're going to plug those into the equation as well. You can see that point has a y value of 6, so I'm going to replace this with a 6. And then I've got 2/3 times my x value of 3, and then I'm adding a value of b. If I simplify on the right hand, or this side right here, the right hand side, 2/3 times 3 is just the number 2. If that's causes any kind of confusion or moments of like you're like, what? Do some multiplication and just verify that that's the truth. So this equation becomes 6 equals 2 plus b. If I take away 2 from both sides, I can see that my y-intercept b must be 4. So I know my slope. My slope is 2/3, and I know my y-intercept is 4. So now that I know my 2 parameters, I can write the equation of this line. The equation of this line is y equals 2/3 x and then plus 4. And it's a worthy step to go ahead and plug in each of the 2 original points we have and just verify that they indeed do satisfy this equation. But I think you'll see that it works nicely. The other technique we used, and I'll mention this here because it's kind of it's nice to try problems in a lot of different ways. This was one of our points. It was negative 3, 2, and the other point was 3, 6. And what we did was we considered y equals mx plus b twice, once for each of the points. So for this point, right, the one I just put a smiley face above, I could write 2 equals my slope m, and then times x of negative 3, and then plus b. And then if I use this other point, the one with the sad face, and again plug those into that same equation, I get 6 is y equals m times a positive 3 and then plus b. And what's nice about this is now a system of equations where my variables in this case are the parameters of the line. So I have the opportunity to figure out what m and b are. And what's super nice about it is you can see that my m's are already opposite terms, right? One's negative 3m, the other one's positive 3m. So when I combine these and use elimination, the m's are gone. So I end up with 8 is equal to 2b, and if I divide both sides by 2, I can see that 4 is b, and that's what we found exactly on the other equation, right? We knew that b had to be 4. And then if you go ahead and plug in this value of b into either of these equations, perhaps the second one, and solve for m, when you solve for m, you're going to get 2/3, just like we did in the original problem. So this is another technique. It's a technique based on kind of using systems of equations and creating two equations from the points, and where you're trying to find the values of your parameters.